Hello, hi everyone. So this is a video regarding to solve a lead code problem. So problem number 19. So we'll be quickly seeing the solution regarding this problem. First, we will discuss the approach of this problem and then we'll jump to the solution of this. So the problem is remove nth node from the end of linked list. Coming to the problem statement, so given the head of a linked list, removing the nth node from the end of list and return its head. Let's understand better it by example. Suppose you have a linked list which is carrying the five element 1, 2, 3, 4, 5, and you want to remove second element from the back, that is fourth here, from the linked list, and the output you will be getting the 1 2 3 5. So this will be the final output. So the input we will be giving the 1 2 3 4 5, and the n, which is the number or steps from the behind of the linked list, which element we wants to be delete from the linked list. So quickly think about this solution of this problem, then we will be uh, going through the solution of this. So if you think, so I will discuss the approach to solve this problem. So there is two approach to solve this problem. First one is a iterative approach, another is a recursive approach. We'll not be discussing recursive approach in this video. So I will be focusing on the iterative approach. So that is a brute force approach. The first approach is here. Suppose you have the linked list, which is carrying the five elements, as you can see here, and we want to remove the second element from the back. So first, what we will do, we will calculate the length of the linked list that will be stored into a k variable, and as from this example we can see the length of this linked list is 5, and, to calculating the length of this linked list will will take one pass from beginning to the end, and after calculating the length of the linked list, so then from the starting we will go k minus n plus 1 steps to remove the element. So basically, k minus n plus 1 steps will be 4 steps. K is 5 here, n is 2 here, and plus 1, 5 minus 2 plus 1 will be the 4. So if we will iterate again from the start of the linked list, 1, 2, 3, 4, we will be comes at this fourth node and we will be removing it. So this is the first approach. So the problem with this approach is that this is taking two paths. Okay. But if I do, if you want to solve this problem in one pass only. So there is another approach where we took two pointer, first pointer and second pointer. So in this approach, uh, we iterate, we will start from the second pointer. Suppose first pointer and second pointer point to the beginning of the node, and we will be moving the second pointer only to the n steps, whatever the steps we are giving. So we are giving given here two steps. We will be iterating from this from beginning node 1, 2. So at 2, the second pointer will come here and the first pointer will be here. So what if I tell you, if this second pointer when it iterates step by step, and when it is reaches to here, and this step first pointer when the second pointer comes to the end, then the first pointer will come here. So this is the solution to second approach, in which in one pass we can solve this problem. So basically we will move the second pointer to the end step from the start when it will reaches the uh, n is equal to 2, basically at the second node. Now if we will calculate the k minus n plus 1 equal to, it will come out 4 for particular to this problem. So these many steps will be left for the second pointer to reach out to the last node, and same step we need from the beginning of the linked list node to reach at that node which you want to delete. So basically, this is a two-pointer approach to do it into a single pass. So now I will be jumping into the lead code platform to show you the code which I have done to solve this problem. So basically, this is a class solution in which we are making a method remove nf node from a. It's taking two arguments. One is head of the linked list, and n is an integer which you the number from the behind of linked list we want to remove. So the approach is simple. First we create the dummy node, and then the dummy node next we initialize to the head of the linked list. Why we are taking the dummy node? It is basically to handle the edge case where we will be not having the any element in the linked list. Okay, and then we will initialize two pointer, first pointer and the second pointer to the dummy node. And as per approach I have discussed, so we will be moving the second pointer to the end step, and this is the edge case to handle. When the second pointer next becomes none, means the n steps we are giving that is more that is more than the length of the linked list. So in this case, we will be simply returning the uh, head of the linked list. Otherwise, we will be until the n steps will not complete, then we will be iterating through the second pointer to the next. So when it will be second pointer comes and steps away from the beginning of the node, then we will move the both the pointers, first pointer and the second pointer from but first pointer at the beginning of the node and the second pointer at the end step from the beginning. When the second pointer next will be none, basically it will be at the last node. Then the first pointer will be at the k minus n plus 1 step from the starting node. So we'll be deleting that. So until this is the while loop, so it will run until the second next uh, pointer becomes none. So basically, when second pointer comes to the last node, this condition will fail and it will come out from the loop, and then we will be deleting the node. Basically, how we'll be deleting? We'll be replacing the first pointer next to the next element. So basically, it will skip the element, and then in the end, we will be returning the head of the linked list, which is basically the dummy node next element. So that's all about this.